What is the next number in this pattern of numbers? In the first sequence, we noticed that 4 is added to the first term 3 to get the next term 7. We always added 4 to get the succeeding number. Hence, after 19, the next number is 22. In the next example, the common difference is -2. Hence, the next number after -4 is -6. These sequences are called arithmetic sequence or arithmetic progression. These are sequences wherein each term is obtained by adding to the first term a fixed number called the common difference. The common difference is equal to a term subtracted from the previous term. In general, if A is the first term in an arithmetic sequence and D is the common difference, then the successive term may be expressed as this expression. Hence, the last term or the nth term of an arithmetic sequence is A sub n equals A sub 1 plus n minus 1 times D, where A sub n is the desired term or the nth term, A sub 1 is the first term, n is the number of terms, and D is the common difference. Take note that a sequence is arithmetic if each pair of consecutive terms differs by the same number called the common difference. The nth term of an arithmetic sequence can be determined using this formula, A sub n equals A sub 1 plus n minus 1 times D. Let us have some examples. Number 1. Determine if each of the following sequences is arithmetic or not. Letter A. The sequence is 45, 40, 35, 30, 25, and so on. Let us see if there's a common difference by subtracting a term from the previous term. 40 minus 45 is -5, 35 minus 40 is -5, 30 minus 35 is -5, and 25 minus 30 is also -5. Therefore, this is an arithmetic sequence. For letter B, 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4, and 16 minus 8 is 8. There is no common difference, hence, this is not an arithmetic sequence. Letter C. 2.3 minus 1.1 is 1.2, 3.5 minus 2.3 is 1.2, 4.7 minus 3.5 is 1.2, 5.9 minus 4.7 is also 1.2. There is a common difference, so this sequence is arithmetic. Example number 2. What is the seventh term in the sequence 4, 7, 10, 13, and so on? First, let us determine if this sequence is arithmetic. 7 minus 4 is 3, 10 minus 7 is 3, and 13 minus 10 is also 3. There's a common difference, which is 3. Therefore, this is an arithmetic sequence. In the problem, we have the value of D, the common difference, which is 3, A sub 1, the first term, which is 4, n, the number of terms, which is 7, because we are looking for the seventh term of this sequence. To answer the problem, we use the formula A sub n equals A sub 1 plus n minus 1 times D. Replace these variables with its given value. We have A sub 7 equals A sub 1, which is 4, plus n, which is 7, minus 1, times D, which is 3. Simplify, 7 minus 1 is 6, times 3 is 18, and 4 plus 18 is 22. Thus, the seventh term of this sequence is 22. Number 3. Which term of the arithmetic sequence 1, -2, -5, and so on is -35? In this problem, tinatanong kung pang ilang terms sa -35. So we are looking for the value of n. Given D, which is -3, the common difference. -2 minus 1 is -3, -5 minus -2 is also -3. That is why the value of D is -3. The first term, A sub 1, is 1, and the last term, A sub n, is -35. Using this formula, we have A sub n, which is -35, equals A sub 1, which is 1, plus copy n minus 1 because we don't know yet the value of n, times d, which is negative 3. And this becomes negative 35 equals 1 minus 3n plus 3. Distribute negative 3 to n minus 1. So we copy negative 35 equals 1. Negative 3 times n is negative 3n, and negative 3 times negative 1 is positive 3. Next, transpose negative 3n to the left side and the constant terms to the right side. So this is equal to positive 35 plus 4. 1 plus 3 is 4. 35 plus 4 is 39. To solve for n, divide the equation by 3. Hence, n is equal to 13. 39 divided by 3 is 13. Therefore, negative 35 is the 13th term of the sequence. Number 4. The third term in an arithmetic progression is 12, and the sixth term is 24. What is the 10th term of the sequence? Here, we have a sub 3, which is 12, a sub 6, which is 24, and the number of terms is 10, because we are looking for a sub 10, the 10th term. Remember that in order to find the last term or the nth term of an arithmetic sequence, we need the first term. And to determine the first term, we need the common difference. However, hindi pa natin alam kung ano ang value ng d. So in order to find the value of d, we let 12 be the first term and 24 be the last term. Hence, our a sub 1 is 12, n is 4, we have here 4 terms, 1, 2, 3, 4. And the last term, a sub 4, is 24. Substitute these values into the equation. We have 24 equals 12 plus 4 minus 1 times d. 4 minus 1 is 3 times d. Transpose 12 to the left side, then simplify. 24 minus 12 is 12, equals 3d. Divide the equation by 3 to solve for d. Thus, d is equal to 4. 12 divided 3 is 4. So we now have the value of d, which is 4. We can now determine the first term by working backward. We start by subtracting 4, the common difference, by 12 to determine the second term. So 12 minus 4 is 8. And then from 8, subtract 4 to determine the first term. 8 minus 4 is 4, which is the first term. We can now determine the 10th term of the sequence, where a sub 1 is 4, n is 10, and d is 4. 10 minus 1 is 9, times 4 is 36, and 4 plus 36 is 40. Hence, the 10th term of the sequence is 40. We can verify this by completing the terms in the sequence. We add 4, which is the common difference to a term, to obtain the next term. 4 plus 4 is 8. 8 plus 4 is 12. So 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. 24 plus 4 is 28. 28 plus 4 is 32. 32 plus 4 is 36. And 36 plus 4 is 40, the 10th term. Number 5. Find k if the sequence 8k plus 4, 6k minus 2, 2k minus 7 is arithmetic. Take note that a sequence is arithmetic if each pair of consecutive terms differs by the same number called the common difference, and the common difference is equal to a term subtracted from the previous term. For example, we have here an arithmetic sequence 4, 6, 8, and so on. 6 minus 4 should be equal to 8 minus 6. We are going to use this relation to solve for k. 6k minus 2 minus 8k plus 4 should be equal to 2k minus 7 minus 6k minus 2. A term minus its previous term. Second term minus the first term should be equal to the third term minus the second term. First, we distribute the sign. So copy 6k minus 2 minus 8k minus 4. Negative times positive 8k is negative 8k, and negative times positive 4 is negative 4, equals, copy 2k minus 7, then distribute the sign. Negative times 6k is negative 6k, and negative times negative 2 is positive 2. Then collect all terms with variable k on the left side and all the constant terms on the right-hand side of the equation. So we have 6k minus 8k minus 2k plus 6k equals negative 7 plus 2 plus 2 plus 4. 6k minus 8k is negative 2k, minus 2k is negative 4k, minus 6k is positive 2k, equals negative 7 plus 2 is negative 5, plus 2 is negative 3, plus 4 is positive 1. Then divide the equation by 2 to solve for k. Therefore, k is equal to 1/2. Thus, the sequence is 8, 1, negative 6. 8 times 1/2 is 4, plus 4 is 8. 6 times 1/2 is 3, minus 2 is 1. And 2 times 1/2 is 1, minus 7 is negative 6. This is an arithmetic since the common difference is negative 7. For problem number 6, if a school offers a monthly starting salary of 20,000 pesos and an increase of 100 pesos per month, what is the salary on the 36th month? This is an arithmetic sequence problem since there is a common difference which is 100. Every month, the salary increases by 100 pesos. So to determine the salary on the 36th month, we use this formula where a sub 1 is 20,000, d is 100, and n is 36. Find a sub 36. Substitute these values into the equation, then simplify. 36 minus 1 is 35, times 100 is 3,500, and 20,000 plus 3,500 is 23,500. Thus, the salary at the end of the 36th month is 23,500 pesos. Number 7. An audiovisual room has 17 rows of seats. The last row contains 92 seats. If each row has 2 fewer seats than the row behind it, how many seats are there in the first row? Again, this is an arithmetic problem since it is stated in the problem that each row has 2 fewer seats than the row behind it. The common difference is 2. N is 17. The room has 17 rows of seats. The last term, or a sub 17, is 92. The last row contains 92 seats. D is 2. Each row has 2 fewer seats than the row behind it. And we are looking for a sub 1. How many seats are there in the first row? Substitute these values. We have 92 equals a sub 1 plus 17 minus 1 times 2. 17 minus 1 is 16, and 16 times 2 is 32. Transpose 32 to the left side and subtract it from 92. 92 minus 32 is 60. Therefore, there are 60 seats in the first row.